Thank you, Albert. Can I get a raise of hands for Albert's great presentation? We do have some questions that came in. We'll start with Dan Wilson wants to know, is non-linearity and hysteresis measured at the worst points or at the points shown in the presentation, 60% and 40%? Great question, Dan. Who'd like to take that?
Hysteresis measure
at the worst points or the points shown on the presentation?
Let me go back to that slide. So here it is. Yeah, so hysteresis is measured at the 40% on the ascending and descending calibration procedure. And it can be done at 50. And in this case, I'm only showing how we, in this case, it's shown at 40 because this graph is representing or is showing the standard calibration procedure, which consists of 5 points up and 1 point down. When we have calibration runs with more than 5 points, what we'll do is we take a measurement reading at 50, and on the way down we'll do that 50% measurement again, and the hysteresis will be determined at the 50% range.
On the calibration, right?
Correct.
Okay, the diagram earlier looks like it had more than 4 gauges. Why was that?
I'll take it. All right, I think they're probably referring to the load cell cutaway that we showed early on. You're correct. There's 4 beams here that would be gauged for this lower capacity unit, and there would be 8 gauges on there. You really only need 4 gauges for a complete bridge. We put 8 gauges on every low profile. The reason for doing that is to lend much better eccentric insensitivity. So putting 8 gauges on there, you can wire them up so that they tend to self-cancel for non-axial loads that are applied. And then we take it one step further with our moment compensation process. So.
Okay, next question. Do low-profile load cells have to have bases? Great question.
I'll take that. Hello, this is Scott Dunn. Generally, we recommend that a load cell is shipped and prepared with a base. We try to maintain 2 10,000ths of an inch or 0.0002 flatness on those bases and on the load cell. So when they're bolted down, the load ring or the mounting ring is shown in Albert's anatomy of a low profile. So they're flat and they're not twisting. Any of that twisting would then show up as extraneous strains and then a force on that load cell. So shipping it with a base guarantees that the flatness is right, and then the load cell will not deflect simply by the mounting of it.
Okay, here's one. What causes zero load shift? Who wants to take that one?
A zero load shift, again, when we prepare a load cell, we'll take a zero balance with no load, no load string on it, nothing on it. Once you then start to apply a load, either attach a load string to it, your zero is going to change. A zero balance can change if there's a shock load or, again, an extraneous side load that could permanently deform the load cell or some of the beams, and therefore the strain gauges take a set to that value.
Okay, this one's from John. How do you take in wear and age into recalibration? How does wear and age affect recalibration?
we get this question a fair amount of times. I run the repair and recalibration department, and people are asking us for recommended times or intervals. Typically, a year would be the minimum, unless you saw a large zero shift in your load cell. If you also see anything that's wrong, if you have a shunt cal, if your shunt cal resistor isn't handled, is giving you the wrong data that you would expect. But as far as wear and tear, if you don't see any damage to the threads, any loosening of the bolts around the outside of the load cell, or any damage to the connector or the cable or the interconnection that you have to the outside world, a recalibration isn't necessary outside of any other damage. Other than that, if you're in an application where you have traceability, usually 1 to 3 years is what a lot of companies that we see are looking for as far as recalibration periods.
So we have a follow-up question to the zero load shift question. What if they haven't seen any load?
A load cell will have potentially could have a zero shift within the first probably within the first year of its life, perhaps. You got to remember that it is a strain gauge, and when the manufacturer of a load cell, you're putting a lot of stress into the metal that we're actually putting the gauges on. We exercise our load cells extensively, which minimizes those changes. So you really shouldn't see that much of a zero shift, but it could happen. If it's going to happen, it usually happens very early on in its life, and then it becomes asymptotic, and the longer the time it's in the field, the less the zero change will occur.
I just wanted to say a few things on that too. It's important to be aware of how you're taking that zero value under what conditions. There's a lot of parameters there. If you're comparing one zero to another, you want to make sure those were done under similar conditions.
Great, thanks guys. Here's a question. Why do load cells have to be temperature compensated?
I'll take that one, Nikki, and for that, what I'll do, I'll refer back to our diagram here, or the chart. This one here. So as the temperature around the load cell is changing, the temperature coefficient of resistance of the metals involved in the fabrication of the load cell, the flexure and the strain gauges, their TCR is changing, and therefore we have a signal, an output signal that is changing as that temperature around the load cell is changing. What we do, and when we add what we do in order to compensate it, is we balance this bridge in order to minimize those errors. What we do is we add wire to either the left or the right legs of the bridge in order to maintain that amount of error as minimal as possible. There will always be some amount of error, but we'll always try to keep that to the minimum possible.
Okay, question about moment compensation. So is that a batch test that is done?
Moment compensation at interface is done individually to each load cell. Each load cell is going to have some distinct variations, whether it's being because of gauge placement, beam thickness, again, anything else with the fixation of the load cell to its base would then cause a variation in the moment eccentric load errors from one load cell to the other. Interface individually moments compensates 100% of its low profile load cells to minimize this error, and we do not do a batch moment compensation.
Great. I'm going to have a last call for questions here. Do load cells have to be machined as opposed to using extrusions?
Okay, I'll take that one. This has come up many times as a way to lower cost of load cells. Basically, what you're looking for is the strain gauge is going to be very sensitive to the grain structure that's underneath it. And the only way to guarantee that is that when you buy the raw material, that you're cutting it and then fabricating it in a way that keeps the grain structure in a consistent manner. An extrusion is really just chop meat. It will you don't get any grain structure or consistent grain structure with an extrusion.
Let me add a little bit more to that, and I'll refer to this image here or to this slide. Yeah, it's also the tolerances that we specify for the height of the beam and also for its thickness. They're only plus and minus 1,000, so it would be very difficult to achieve those tolerances in a extrusion process. So therefore, we have to basically machine every flexure from scratch.
Okay, we've got another one here. What standards do you use when calibrating high precision load cells?
Okay, again, the question is, what standards do we use? Okay, all of Interface's standards are traceable or sent to NIST on a periodic basis for recalibration. We also produce or participate in what they call round-robin proficiency tests that guarantee that our results match other labs across the country. And we also, part of our data acquisition is the gold standard software that we also offer that was written in-house that allows us to take that data at very precise points along with the control of either the hydraulics or a dead weight calibration.
And I just want to clarify too, Scott, correct me if I'm wrong, but some of those standards go back 25 plus years, even older, correct? We have history on those in terms of how they perform going back that far.
They are quite old. Some of the standards are well over 30 years old.
Okay.
Great. Well, I think that wraps up our Q&A session for the day. I want to thank everybody for joining us today and your patience with our technical difficulties from last week. We really appreciate you being here and your participation, and we hope you have a great rest of your day. And happy Labor Day. Have a great long weekend. Bye, guys.